The DevOps Mindset with René Schumacher.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be highly effective and able to deliver world-class results through its ClearMeasure way for effective software teams. My architect forums are still going strong and signups for the next session are up. We'll put a link to that in the show notes. And if you lead a .NET software team and are looking to collaborate with peer architect leaders, then just go ahead and sign up for that at the link in the show notes. And for those of you who are looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories and you'll be able to find it. So the guest today on the show is René Schumacher, and he's a principal cloud solutions architect in engineering, a CSA-E, and technical lead for Azure DevOps and software development processes at Microsoft in Germany. In his role as a principal cloud solution architect, he helps customers adopt good development practices and processes, as well as understanding the principles of DevOps. And as an Azure DevOps expert, René trains customers for using the DevOps toolchain and shows ways to integrate Azure DevOps into existing heterogeneous environments. But before starting his career at Microsoft in late 2008, René has been working as a developer of enterprise logistics systems for almost 10 years, and probably more than 10 years at this point. René, welcome to the show. How are you, sir?
Hey, welcome. Thanks for having me. I'm great. Actually, a little stressful week, all kinds of things going on. Been talking more English than German during the week. So this might help with the podcast.
Very good. We appreciate the time. Now, before we kind of dive into the technical questions, for those who maybe haven't worked with you or heard you speak before, just go back. You joined Microsoft in 2008, but even before then, what are the major points in your career that kind of guided you into this field of work and then landing in software engineering processes?
Yeah, well, I started studying IT back in, 1997 or so, before I quickly realized that just going through the stuff theoretically wasn't really my cup of tea. So I quickly moved into more practical things. And during the early or the late 1990s, I would say, you saw the first Agile principles popping up, like there was Scrum in 1995 or extreme programming. And I started looking into these fields, even though I was never able to really work in an Agile way in my old company. We were very classical, like doing project plans and Gantt charts and all these things. And I always felt that this was not the right thing to do.
Yeah.
So I tried to push agility into the company I was working for. I didn't really succeed, even though I could get them to stop writing like 300 pages, functional concept specifications and all these things. And the moment I saw the opportunity to jump to Microsoft, that's what I did, because I was always like the youngest in the company. And I tried to do new technologies, new principles like unit testing. There was no automated testing at all when I started at that company. And I really had a hard time to push all these principles that I loved. And so when I moved to Microsoft, and quite funnily, I started as an expert for Windows CE and Windows Mobile, which is not the most agile environment, I would say.
Yeah, embedded.
Embedded is, it's harder to do because it's not all software, it's limited software by the constraints of the hardware. And that stopped. I quickly jumped over to processes and all kinds of things, which made me kind of special inside Microsoft because we were part of the support organization. And so we usually help people when their Visual Studio crashed, or I don't know, to install Team Foundation Server, as Azure DevOps was called back in the days.
Mm-hmm.
And so I somehow just slipped into that process and Agile and coaching space.
So you've worked in the 90s before Agile caught on, whereas, of course, the people who maybe have been in the field for 5 years, they never knew a time when it was a debate about this quote new Agile thing. So in your short summary, just for all of those listeners out there that were not working back then and did not go through that journey, how do you define the real difference, the real meaningful difference between the 1990s waterfall mindset and the Agile mindset, just from a process perspective?
That's actually a pretty good question. I would say the biggest difference, where you can really feel it, is that Agile just accepts uncertainty. So everything we did back in the 1990s with all the planning and things is like we tried to manage uncertainty, which never really worked out. So no matter how much you plan, no matter how much you analyze, there will be things happening during your project, during developing a product, whatever you do, that you can never see coming.
Mm-hmm.
And so instead of just trying to get rid of these uncertainties and lying to yourself essentially about, I know exactly that we're going to finish on that specific date or with that specific scope,
Mm-hmm.
I would say the biggest change is that Agile just accepts uncertainty and builds around practices to just go with it. So if there's something happening, Agile has a practice that helps you change direction and pick up speed again. That's to me the biggest difference. It's not all about sprints or whatever. These are just implementation details. It's really this accepting that there will be uncertainty and just building muscle memory or building practices so you can work around that uncertainty. That to me is Agile.
Okay, great. And then your view of DevOps. Is DevOps an extension of Agile, or is it a successor? How do you view, what's the difference between Agile and DevOps?
I always tell people that to me, DevOps is an evolution of Agile. When you think of classical Agile and look at stuff like Scrum, for example, Agile has always talked about one team doing one product, maybe two teams, but it never really scaled. And Agile, so that things like extreme programming or Scrum or whatever, they never really cared about the rest of the company, the rest of the people, like the analysts and the marketing people and business and whatever. So it was always the little team. And we've learned a ton during that time when we focus on the team, like good communication is key, working incrementally is key, like having feedback loops all over the place is key. And now when I look at DevOps, I always tell people DevOps is like taking everything we've learned and applying that to the full value stream. So starting with the people who have an idea about a product, starting with communication with customers, and then going all through analysis, design, and all the way down to operations and support and all these other functions that have never traditionally been part of Agile. So to me, it's the same principles, essentially, maybe with a little more to it, like we do infrastructure of code and we may be more focusing on automation. But certainly to me, automation is not the goal of DevOps. It's just a tool in our toolbox because human beings don't scale as well as automated systems. And so if people think about DevOps, they should think about how can I change my culture to be agile end to end? And so it's an evolution, in my opinion.
So you said automation is just a tool of DevOps. Automation is not DevOps. So if DevOps is not just about automation, then in your mind, what is DevOps all about?
So when I talk about that with customers or when I teach that to customers, we usually use two different definitions of DevOps and not even the official Microsoft one, because Microsoft has an official DevOps definition, which is something like DevOps is the union of people, processes, and products to achieve continuous delivery of values to our customers, which is somewhat good. But we use a different sentence. We say our goal is to find ways to deliver high quality and high value products in a fast, efficient, and reliable manner. And that is certainly just describing the way we think about DevOps. And then, of course, we're always using the 3 ways from the Phoenix project from Gene Kim, that's his name, sorry. So the first way of maximizing flow, then the feedback way, and this culture of continual experimentation and learning, that to me is DevOps. Or if you want to focus on automation, it's like finding ways to get rid of all these non-value adding practices. And you do that by either stopping doing them, like don't go to any status meetings anymore because there's better way to convey status. And all the things that we have to do, even though they're not value adding, we try to automate them away. So to free up capacity for human beings, I always say, use human beings for things where you need a brain. Mm-hmm. If you don't need a brain, if it's a repetitive task, don't use a human being. You're wasting a human resource with something like this.
Yeah, I like that. And yeah, you mentioned the Phoenix project, which I think at this point, a lot of the people that came into the industry, post 2020, they might have even missed the industry conversation about the Phoenix project and then defining DevOps and how we should think. And so the 3 ways, can you kind of review those again? What are the 3 ways of DevOps?
So the first way essentially is described in the Phoenix project as maximizing flow, or we always also say system thinking. So when you think about maximizing your value stream or your production of value, it's all about understanding how to increase the flow of value. And what people rarely realize is we're so tuned to doing micro optimizations, like I'm in this silo and I'm optimizing myself, that we forget that every optimization that we do has some impact either on the upstream processes or the downstream processes of the work, of the value stream. And so this first principle is take a look at your full value stream, understand that, and realize the impact it's going to have if you change something here or change something over there. And there's I always also explain the theory of constraints when I talk about these things. There's a good example, I think, in Kent Beck's book, Extreme Programming Explained, where he used something like doing your laundry for the theory of constraints. And quite simply put, it just means every process will have a bottleneck. And no matter what you do, you're just moving the bottleneck around. You're never going to get rid of it. And so once you've realized that, and once you understood what your value stream is, you can do optimizations that actually increase your flow. And you can exploit bottlenecks. You can try to get rid of them as quickly as possible. And then the second way essentially builds on top of that, because if you want to change something, you always need to figure out whether the change was good or bad. So the second way is the feedback way, which allows you to actually learn from whatever you did. You get feedback internally, you get feedback from your customers, you get feedback across the board, which helps you move into that continuous improvement cycle that is part of Agile. That's also why I say, to me, DevOps is just an evolution of Agile. It builds on top of the Agile principles. And once you've learned how to get feedback, you can move into what I think is the most important way, the third way, which is this culture of continuous experimentation and learning, which is especially needed if you're going to be innovative. Innovation doesn't come from the market. If you just go out and ask people, what do you think the new next big thing will be? They might have an idea, or mostly they won't. Or I like to cite Henry Ford here. He allegedly has said, if I had asked people what they wanted, they would have answered faster horses.
Yeah.
Because no one could have imagined a car.
Right.
And so if you want to be innovative, you have to come up with an idea. You make an assumption that this is good. You build the smallest possible thing to verify that, bring it to the market, and then you see how the market reacts. So you measure, get feedback, essentially. And if it was good, you continue to build on top of that. If it was bad, you just stop and start from scratch. And because you're doing that in very small iterations, it doesn't hurt as much if you fail. So you can follow this principle to fail fast, which is also part of Agile, because it hurts less and you will lose less money and all these things if you fail pretty fast.
Yeah. So when you're talking about iterating quickly and doing that fast, what's your definition of quick? Do you subscribe to a 1 week or a 2 week or a 3 week, et cetera, cycle? What's your view on that?
That's almost a philosophical question, I think.
Yep.
So I definitely go with the Scrum definition of a sprint. So I don't like iterations to be longer than 4 weeks. Most of the time, I tell people start with 2. I think 2 is a good place somewhere in the middle.
Mm-hmm.
You can increase your sprint or your iteration time. You can decrease. Of course, it depends on what you're building. So if you're building only software is so malleable that you can actually build stuff very, very quickly. If there's hardware involved, or if there's all kind of communication across different teams, you might need a longer cycle, because all of that conversation and the collaboration will take away time from your actual work time, from the actual time you can spend on creating value. So it really depends on the circumstances, but I'd like to start teams with a small iteration. And if they fail, I even make the iteration smaller, because there's a good chance that they're falling into what's sometimes referred to as Parkinson's law, which means if you give someone time to do a task, that someone will use up the time.
Gotcha.
Whether they need it or whether they fill it up with other things.
So you would shrink that down to a week or less?
I shrink that down to a week. I wouldn't go less, because less than a week is really, it's weird, because you have the weekend in there and you never have a natural cadence. So I wouldn't go below a week. I would also never start my iteration on a Monday and end on a Friday. I would always start within the week, just to make sure that there's no, let's say, gap between those iterations.
Yeah.
Otherwise, people might just work through the weekend, and you don't want to overwork your people. So it's important that you have a natural cadence, that you can also plan all your what's it called? Your ceremonies. If you want to follow something like Scrum, like planning and whatnot, you should have a fixed day for these things. If you go below a week, it will be on Monday in the first sprint, and on Wednesday in the second, and on Friday in the third. It doesn't really make sense.
Yeah.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast, or by visiting palermo.network. Tune in today.
You made a good point. If you're doing software that, let's say, is embedded into some physical devices, then you've got some pretty hard dependencies where you can't just, like, if it's just a website, you could click a button or trigger a build and you could have a spelling error, fixed immediately, in the mid-morning, zero downtime, and that's fine. But if you're pushing software that's going to be installed in a IoT device, and then those IoT devices need to get out into the field, and then only then will you get some actual production telemetry back, then you're going to have a different cycle. So if a team, or maybe an organization with multiple teams, has different software with these different characteristics, then in your opinion, should those teams have different iteration lengths to align with those businesses? Or do you think an organization gets synergy by just forcing all the teams to standardize on a length?
I would never, just for the sake of standardize across all my teams. Of course, it makes sense if you have 10 teams delivering into one product, that they share a kind of cadence. Because, in the end, they need to deliver something integrated every time. And it's harder to integrate if your sprint ends in the middle of the other team's sprint, and then you want to integrate, but they're busy hacking away on a feature or something. So in this case, I think it makes sense. When you have a strong dependency on hardware, and I had an interesting chat with the head of Surface a couple of weeks ago, We just figured out we both don't know the real answer, so we're both still learning. But if you have a strong dependency on hardware, my take on this is try to get rid of that dependency as much as possible by simulating your hardware for the software people, because usually hardware can be developed without the software. But you need the software somehow to figure out whether the hardware is working correctly or not. And of course, in the end, you need the software to actually run the hardware or run on top of the hardware. But what most people don't do, even inside our Surface team, as far as I learned, is we simulate a lot for hardware. We do all kinds of simulations on how the hinges work and whatever. But we're so bad at simulating something like, let's say, a camera where you have to build the driver for.
Right.
So we wait until the camera is there, and then we build the driver. And if the camera was late, the driver will be late, and the release will slip, and all these things happen. So if we invest a little more in building these like infrastructural pieces, like the shims and whatever simulations,
right,
I think we would be much better off than we're in most cases today.
Yeah, that makes a lot of sense. So you have done a massive amount of work with the Azure DevOps product and integrating it into all kinds of things. And so across all the customers that you've helped, in your mind, do you have a certain category of software architectures that have emerged that things fit into? Like you mentioned, software that goes into hardware. And then, of course, you have just things that are largely cloud website. Do you have in your mind a set of categories of architecture that you think everything can be dropped in at this point in 2023?
No, I don't think so. So certainly people might say now, of course, it's microservices or whatever. But again, to me, all these things are just tools in our toolbox, and we have to choose the right tool at the right point in time. What's interesting is that I think the most successful, what you want to maybe call DevOps companies, like the Amazons, the Netflixes, and all the other big companies, they are cloud companies. They have a software product running in the cloud because it's much easier to just do, I don't know, just continuous deployments or rolling updates without customers even noticing. When you have something like, you said, an embedded device, an IoT device, or even have to work a lot with car manufacturers, if you build software that runs on the device inside the car and makes sure that everything is running smoothly, you're going to have a harder time. And certainly something like, for example, a microservice architecture will not fit into that. But I believe the key to me is to find an architectural principle that makes it possible for teams to work as independently as possible. And this is why most people might reach out to microservices, because the design itself of these autonomous services really fits autonomous teams pretty well.
Yeah.
But if you cannot make it that way, you just do whatever, a monolith, but make sure that at least your components inside the monolith are somewhat isolated. So you try to come close to this isolation model, even if you're building a monolithic application that's running on a device. So that would be my take on this. I'm not so much a blueprint guy. Use this for this and use this for that. I've seen so many things that worked in one environment fail in the other, even though the environments might be similar. But you should never forget that it's not just architecture and design and software or development language. It's also the culture inside the company that really drives your success, whether you're succeeding with a monolith or a microservice architecture is also dependent on the culture.
Okay.
So don't forget about these things.
Gotcha. So with all of these environments, what type of test automation do you find yourself recommending a lot? I mean, people talk about unit testing. Okay, great. There's books on unit testing. But out of all the different types of test automation that you could do, what do you find yourself recommending a lot?
Quite honestly, I would say I also keep pushing unit testing because to me, that is the foundation of automated testing. It's like you cannot build a house without laying the foundation, and you shouldn't think about automated testing if you didn't do unit testing. So it's the starting point for everything, because I always like to say there's so many different test types, and people try to use every type of test to test functional correctness, even though, for example, an integration test, in my opinion, doesn't test functional correctness. It tests all kinds of things. So you shouldn't even try to do that. It's like building your house and then shaking it to see if it doesn't fall apart. That would be the integration test. No one does that. So we will always test the different components of the house, the different building blocks, like the bricks or the mortar or the windows or whatever. But in software, we somehow decided to just build the house and then shake it. And so I keep pushing people to unit testing. And even though I'm not that, let's say, scientific about unit, what a unit actually is, I don't care if it's a function or if it's 3 functions inside a class or whatever. I always say a unit test for me is a test that is very fast, does not have any external dependencies. And if it fails, you can point your finger at the problem. If you have to analyze why the test fails, and it might be this or that, you haven't written a unit test. You have written some kind of integration test. And these are fine, especially if you have to test things that are not under your control. So if you need to integrate with an external system and you don't know how that is built, and maybe they might not even have honored the contract. So you want to do some integration testing as well. But the foundation to make sure that your stuff is doing what it's supposed to do is going to be unit testing. And then, of course, if it's about a large product, you should never forget about stuff like load and scale testing and security and compliance and all these things. But when I think of testing, or it's maybe even when I think of DevOps, what I told a couple of customers a couple of weeks ago is we have, let's say, a problem that previous generations, quote unquote, of DevOps people did not have. They had the luxury of taking one step after the other. So they try to solve a problem and then they solve the next one and the next one. But in today's world, you can read a ton of books and blog posts and everything about DevOps. And so people believe that you have from scratch to do all these things like unit and compliance and integration and CI and CD and all these things. So we don't allow ourselves the luxury of iterating when we implement our process. And so the same goes for testing. So don't forget about any of these testing strategies. Like you have to do load testing, at least if you want to have a scalable system, if you want to know how your system behaves under stress. But the most important thing to me is get your code right. And this is unit testing. In addition, unit testing also has a very positive impact on your architecture and design, because you're building a testable product. And that is automatically a product made up of more components, clearer interfaces, and all these things, which also helps you to, let's say, decouple from other people. So if you have a clear interface to other teams, guess what? You can test up to that interface. You can simulate the other team. And all of a sudden, just because you did test automation, you have a way to decouple and get rid of dependencies.
Yeah, that's a very, very good point. Now, further down the line, maybe not exactly testing, but verification and feedback, telemetry and observability, and then, of course, this new standard of open telemetry. With a DevOps mindset, what is your view and what do you tend to advise people when it comes to getting information back from a system that's running in an environment?
Yeah. Again, that I think is a very hard question, because there was a sentence from the back in the days head of Azure DevOps, and he said, we're just going to record everything. So we want to know everything. We want to know all kinds of, behavior data and stack traces and user behavior things. And we want to run our experiments. And of course, you do all the traditional monitoring stuff like CPU and whatnot, which I think it's almost like a drug. If you start gathering the data, you always want more and more and more. So you have to strike the balance between overdoing it especially if you're in Europe and you have these strong data security and data privacy regulations, you should be careful with what type of telemetry you're using. Then again, without telemetry, unless that system is running on your PC or on your premises, you will never have a chance to figure out what's really going on. So you have to track telemetry, especially when it comes to correlation in a system that has many moving pieces, like a microservice architecture. If you really want to understand the flow of a request going through all your services, that needs some kind of telemetry and correlation data to actually make sure that you understand that. And then, of course, if you really want to do this optimized flow feedback and experimentation, telemetry is a core part of that. That is your feedback from the customer, whether it's just how often was this feature used, or how often did people enable this or disable this, so you know exactly what's going on. So telemetry to me is always a very important part, but quite honestly, because most teams even struggle with the, let's say, more foundational principles, I don't talk as much about telemetry as I'm probably talking about architecture design and testing.
Okay.
Even though that is very important, I think there's good tools that give you telemetry almost for free. I don't want to advertise any Microsoft tool here, but there's something in Azure you might be using.
Sure.
So you can do at least a good amount of telemetry by just injecting a good telemetry library and have it all be generated for you. And then, of course, telemetry is something that needs maturity in the team, because I don't think it's feasible to just gather everything.
Yeah.
You have to learn what information you're really needing. And maybe it takes an outage or something where you realize, oh, we found a blind spot. Let's add some telemetry here, or let's add some logging over there. Because otherwise, you're going to drown in data. Even though this might be interesting now with the whole AI movement coming up. And I know that we inside Microsoft are trying to use machine learning, or we are using machine learning algorithms to find different behaviors in our, let's say, to find the signal in all the noise. Like you really want to spot these special moments in time where something out of the ordinary happened. And because of the sheer amount of data, no human being will be able to do that.
Yeah.
So that's the downside that comes with telemetry. You want to gather as much as possible, but you also want to be able to look through that. Otherwise, you're going to end up like the Windows Insider team that did not look at the telemetry or at the feedback. And so you let down people because you're not reacting to the signals they're sending.
I think there's a story behind that. But
yeah.
Well, Rene, I really appreciate you coming on the show. I mean, a lot of information packed into the conversation here, so I appreciate it. For people who want to learn more, maybe dig in on some of the things that we spoke about, we'll include links in the show notes and the the 1999 Extreme Programming book, the Test-Driven Development book that you mentioned. Are there any other resources or things that you want to call out before we wrap it up?
I think the Phoenix project is definitely one of the resources I always like to point out. To me, it's one of the most brilliant books about DevOps, especially because it's no textbook. So it's so easy and fun to read. And it's not just that you learn a ton about what are the principles and the ways you think about DevOps. It's also these stereotypical behaviors that you find in the book. So I recommend everyone to read the book. And when you're done, ask yourself, who in my company is Brent? And who in my company is Sarah? Because you're going to have a Brent in your company and you're going to have a Sarah in your company, the person behaving that way. Yeah. So it helps you look at your company from a different angle. I also like to point out the sequel to the Phoenix project, the Unicorn project, even though this is not about DevOps, it's more about digital disruption and thinking about what you're doing right now, what you probably shouldn't be doing, and thinking about Horizon 3, what you're going to do tomorrow to stay relevant. Apart from that, I think I'm always referring back to the classics, like The Mythical Man Month, in my opinion, is a very wonderful book that tells people it's not just enough to put resources behind something.
Yeah.
human beings just don't scale as well. So you have to change your practices, which also goes a long way to a customer a couple months, or maybe it's even years back, said to me, you know what? Agile is just doing what we always did, just faster. No. That's not going to work,
right?
Because our processes are not designed to be just faster.
Yeah.
And so this is the thinking, like in the Mythical Man Month. If we just put 20 more teams in, they're going to finish earlier.
Right.
So it's all these things. I really draw ideas from these classical books. Definitely Test-Driven Development, or The Art of Unit Testing is a very good book I like to recommend. I haven't fully read through the SRE book from Google, but I think I would recommend that as well, because it talks about some of ideas I've never thought about, like this error budget that people have.
Mm-hmm.
Like when you think about uptime, like 99.99%, everyone is thinking of uptime. But what about the other 0.001%?
That's still hours.
And you can spend that on good things. You can break your system deliberately, which I found very interesting. I've never thought about that way, but sometimes that's what you need to do in order to become better. You need to tear something down and build something new. And if you do that within your error budget, that's wonderful.
Oh, interesting.
So you shouldn't strive for 100%, because that's not doable anyway.
Right. Yeah. You'll get surprised. Awesome. We'll include all those links in the show notes. Fantastic. Well, Rene, thank you again so much for coming on the show. It's fascinating. I love learning from experts like you.
Thank you.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.